In this video, we're going to focus on typing in a 1-prop-z interval on the TI-84. Now recall how to determine if something is a 1-prop-z interval. The data set or the scenario given needs to be qualitative. Now, if you're still confused or if you're not sure what makes something qualitative, please refer back to the flowchart from the beginning of this module to help you decide if this is a scenario that fits a 1-prop-z interval. In this case, we're talking about student-athlete supplements, and we are asking athletes if they take supplements regularly. And so this is telling us that it is a proportion problem. It even says the word proportion at the beginning, which is a keyword. So lots of indicators that it's a 1-prop-z interval. So from here, we know we're going to go to stat, test, and we're going to find 1-prop-z interval. Option A, hit enter, and it's going to ask you for 3 things: X, N, and your C level. Anytime you're filling in your input screen, always fill in what you know from the problem. In this case, it says you have a sample of 150 athletes, so I know my N is 150. I also know my confidence level is 99.99. The only thing that I'm unsure of is the X. So to figure that out, X is the part of the 150. So how many athletes out of 150 said yes? What we do know is 60% of the 150 said yes, they take supplements regularly. So what we need to do is, 60% of 150, well, how many people does that represent out of the 150? I know it's a little bit more than half because 60%. So you can kind of try to figure out, what number that would be based on the context clues. You could also just play around with these values. You could also set up a proportion and solve for the missing variable X. There's lots of ways you could do this, and all of them are acceptable. So in this case, I'm just going to show you kind of a process of elimination, what we could do with these values. So 60% and 150, I could take that 60%, convert it to a decimal, because your calculator only works in decimals, and do something with the 150. I could divide it by 150 and ask ourselves, does 0.004 make sense? If we're talking about people, how many people said yes? 0.004 does not make sense. We could try switching those values and see what we get. 250. Would it make sense to say 250 people out of 150 said yes? Doesn't make sense because that's too many people out of your sample size. So that doesn't work either. The next thing we could try multiplying 0.60 times 150, and we get 90. Does that make sense? So if we think of half of 150 is 75, we know it's a little bit more than 75. 90 in this case makes sense. So in this case, 90 people, 90 athletes said yes out of the total 150 total athletes. And remember, this is creating your p-hat. This equals 0.60, which also equals your p-hat, which is a symbol that we use for proportion, sample proportion, which we know we've used so much. And so that's just a little refresher for you. So let's go back to the 1-prop-z interval, option A. And now we know X. X is 90, so the 90 here. How many out of the total? Think of this as part to whole, part out of the whole. So it should always be smaller than the 150, and it needs to make sense. Hit calculate, and boom. We have our confidence interval. This is our output screen. We have we're going to round to 1 decimal place, 0.5, and 0.7. So in context, we can say we are 99% confident that the proportion of student athletes who take protein supplements regularly is between 50 and 70%. And that is your one prop Z interval helpful video.